Welcome, class. We're going to do a very important topic in physics. We have already uploaded a video on pressure conversions, and we are going to focus on pressure itself. So pressure in physics, why I like physics so much is we don't do a lot of definitions. So it's all about calculations, writing formulas, knowing what they represent and the SI unit, basically. That's what we are doing here. So pressure is force all over what? Area. I'm going to give you two very important formula for calculating pressure. And immediately I'm done, I'm going to start using those formulas to put those formulas in use. So pressure is force all over area. Force is measured in newtons, and then the area is measured in what? Meter square. Therefore, the SI unit of pressure is Newton per what? Meter square. In mass, whenever you have 1 all over A, it is the same thing as what? A minus 1. That is law of indices, the inverse law. So you can see we have Newton per meter, Newton all over meter. So it's either I'm writing it Newton per meter or I will write it like this: Newton meter minus 2. Are you saying it? Good. So pressure itself is force all over area, and it's measured in what? Newton per what? Per meter square. Now, I want you to know something very important. Force is the same thing as what? Weight, because weight is measured in what? In newtons. Now, weight is the product of what? Mass times what? Acceleration due to what? Gravity. And then I want to use this thing to what? To formulate another formula for pressure. If force is equals to weight, and like I said, weight is also what? The product of mass times acceleration due to gravity. Then what I'm going to use is, I will now change this formula. Since pressure is force all over area, now whenever I see force, I will replace it with more what? Mass times what? Acceleration due to gravity. Are you seeing it? Now, all over area. Now I want you to know something. Density is mass all over what? Volume. Now what I want to do right now, let me call this equation 1, and let me call this what? Equation 2. So basically what I want to do right now is I want to make mass the subject of the formula. So therefore, subject of the formula is mass is equals to what? Density times what? Volume. And this is what? Equation 3. Now look at what I want to do. I want to put equation 3 into equation 1. What am I saying? Wherever I see mass in equation 1, I will replace it with what? Density times what? Volume. So putting equation 3 into equation 1, that means that pressure from equation 1, which is mass times what? Acceleration due to gravity all over area. Now wherever I see mass, I will replace it with this. And this will give me what? Density times volume times what? Acceleration due to gravity all over what? Area. And let me call this equation what? Equation 4. Now look at what I want to do right now. Pay attention very well. Now what I want to do right now is, I'm going to have to now, we are in equation 4. Now I want you to know something. Volume is equals to area times height. Volume is area times height. And I'm going to call that my formula equation. Let me write it here. I'm going to, volume is area times height. And I'm going to call it equation 5. Now look at what I want to do. I want to put 5 into equation 4. So wherever I see volume in equation 4, I'm going to replace it and put what? Area times what? Height. That's what I want to do. And then therefore this formula will now change. So remember, I have pressure is density times volume times acceleration due to gravity all over what? Area. Now whenever I see volume, I will replace it with what? Area times height. So therefore this is now equal to D times, rather than volume, I'll write what? Area times height. All over what? Area. Remember, I have acceleration due to gravity here. So basically, this area will cancel this area. Therefore, pressure is equals to density times area times what? No, sorry. Density, because area has cancelled area, so we have density times height times acceleration due to what? Gravity. This formula is very important. Throughout the course of this video, it's either I'll be using any of this formula, but the most important one I'll be using is this formula and then this formula. Please, I want you to know how I drive it, because most times I can use this formula to solve, I can use this one, but like I said, throughout the course of this video, I'll be concentrating on using these two formulas. Are you with me? So it's not that difficult. I am trying to prove all these things for candidates that are writing WAEC, and for those that are writing JAM, you can also know how those formulas are being gotten. Now let's go to an example proper. From the board you can see a very beautiful example. Now this question used to come out either in WAEC, JAM and NECO. It's a very, very important question for us to use to understand the use of those formulas above. Now, since I've proved the formula, you can see our board is not that big. So let me clean some parts. Good. Now, using the above, you can see the question that a rectangular tank, water tank of weight 4.5 times 10 to the power of 3 newtons, measures 2 meters by 1.5 meters by 1.2 meters. Calculate the minimum pressure it can exert when resting on a horizontal surface. This is 8th place. Now, in physics, for you to be very good in physics, all you need to do whenever you are reading question, please try to bring out like now we have a rectangular tank of weight, so we have weight. So weight is 4.5 times 10 raised to the power of 3 newtons. It measures, so we have 2 meters by 1.5 meters by what? By 1.2 meters. Now they want us to calculate the minimum pressure. Now this question every year it comes out either in WAEC or NECO. Whenever you see minimum pressure, what they want you to actually calculate is you should calculate the pressure using the maximum area. It's a hack. So all you need to do is, and whenever they are talking about calculate minimum pressure, they will always give you a 3 quantity like this. Now you can see that we have 2 meters by 1.5 meters by 1.2 meters. Now, if you calculate all these things, you will now notice that it will be in meters. I want you to know something. These 3 quantities are volume. And remember, in the formula we already proved that volume is area times height. And volume is measured in meter cube. Remember that area is measured in what? In meter square. So if I want to get the greatest area, all you have to do right now is first, you will now say 2 times 1.5 is equal to what? Then 2 times 1.2 is equal to what? And then 2 times, or 1.5 times 1.2 is equal to what? Why are you doing this? You want to know the area that is the highest here. The area that is the highest. You can see that 2 times 1.2 should give you around 2.4, and that should not give you what we need. 1.5 times 1.2 will not also give you the quantity we need, but you can see that 2 times 1.5 will give you 3. This one will give you around 2.4, and this will also give you lesser. So I don't have calculator with me right now. So the maximum area is this one, because this is the greatest number. If you times this with this, you will get, I don't think you will get up to more than 3. Good. Now So the area we're going to use is what? 3. Remember please that 3 is measured in what? In meter square. This quantity also is measured in meter square. Note that it's very, very important. Because area is measured in what? In meter square. Now, so all we need to do right now is we have weight, we now have our area. So remember that pressure is force all over what? All over area. And the force is what? Force is equals to weight. So we have 4.5 times 10 raised to the power of 3 all over. Our area is what? Is 3. Remember this is measured in newtons and this is what? In meter square. So if you divide that value, what you should get is 1.5 times 10 raised to the power of 3 Newton per what? Per meter square. Remember that's the unit of what? Of pressure. Very, very important. Don't forget it, please. Remember, whenever they are asking you to calculate the minimum pressure, what you should be concentrating is how to get the what? The highest or the maximum area. Now, in some questions, they will ask you to calculate the maximum pressure. If they ask you to calculate the maximum pressure, what they want you to get is the what? The minimum area. Please note that very well. It's very important. It's very important. Now, we have a another question here. You can see, you can pause the video, and solve it yourself using the formula we have already proved at the beginning of the lecture. So, a reservoir is filled with a liquid of density 2000 kg per meter cube. Calculate the depth at which the pressure in the liquid will be equal to what? 9100 Newton per meter square. Now, remember, we said that pressure is what? Force all over area. And we use this formula to also arrive that pressure is what? Density times what? Height times acceleration due to gravity. Yes, we proved it. So all you have to do right now is what? Make H the subject of the formula. Please, I want you to know this. We already said that pressure is measured in meter in Newton per meter square. You should also know that density is measured in law. Kilogram what? Per what? In kg per meter cube. Yes, because density is what? Mass all over what? Volume. You should know that height is measured in meters. Why acceleration due to gravity is what? Meter per what? Second square. Those are the SI units. So from here, all I have to do is make what? The height the subject of the formula. So your height will just be what? Pressure all over what? Density times acceleration due to gravity. Now, my pressure already given is what? 1900 all over your density is 2000 times what? Acceleration due to gravity, which is 10. And if you should press that, you should get a simple answer of what? 0.455. Remember that our height is measured in what? Height is measured in what? In meters. And that is the answer. So simple, guys. Practice it. Solve more examples.